Hey, I just realized that there was something pretty important that I forgot to go over, so I'm going to do that real quickly. I have a position versus time graph here, and I've gone ahead and make a line that's about 1 meter per second, so it goes up 1 over 1, and then up another 1 and over 1. It's not quite right, but you get the idea. So we have an equation that is velocity is equal to the change in displacement over time. That is an x, I promise. And so I want you to make sense of this. Why is it that slope, right, the slope of this line gives you the value here? If this is 1 meter per second, how do I know that that's 1 meter per second? Because it's the slope, right? And then I should put this, as a horizontal line on the 1, right? This is the 1 meter per second mark here. And so why does that work? Well, slope is rise over run. It's how much it goes up versus how much it goes over. So it's x divided by t. And so anytime that you have any equation at all, ever, where you have one thing divided by another, take the thing in the numerator, put it on the y-axis. Take the thing in the denominator and put it on the x-axis. Graph it, take the slope, you've got your answer. Anybody who knows anything about Excel, and I would like you guys to learn a little bit about Excel and Google Sheets this year if you don't already, that comes in super handy. Not just physics, but in the business world and the science world, it's amazing. And there's something else that I really wanted to talk about that's really important. So by the way, that is a derivative, but not terribly important. But there's also something else known as an integral. The terminology is not important here, but what is important is to recognize something. So let's see, we want to look at a moment where we have an equation where two things multiplied by each other gives us what we're looking for. So in this case, I'm going to multiply each side by t, and that gives me velocity times time equals the change in position or displacement. So for this segment between 0 and let's say 4 seconds, what is my displacement, right? My time of 4 seconds and my velocity. Of course, you can just take your velocity of 1 and multiply it by 4, and you would get 4, right? It would be 4 meters is how far you went. But it's not always that simple. So what I'm going to do here is I'm going to take from the line and go down to the x-axis, and I'm going to shade all this area in. And this shaded area, take the area of it, and that gives you 1 times 4 gives you the displacement. Of course, it's really easy in this scenario. However, it can become more complicated when you have segments. I'll just change colors here. When you have segments that look more like this, okay? So what if I had something that looked like that? Trying to get the displacement of this object that went forward, then it stopped, I'm looking at a velocity graph. So it was accelerating, and then it was constant velocity, then it slowed down, changed direction, it was going in a negative direction really fast, and then came back and came to a stop again. And so what is its displacement? So what I can do is I can actually kind of shade in all this area, right? This whole area between the line and the x-axis. And I would do the same thing here. And all of this would be negative displacements. And you can, of course, break it up. Okay, you can kind of estimate that kind of is like a triangle, figure out what the area of that segment is. And, that's sort of a triangle. What's the area of that segment? And calculus makes this whole thing a whole lot easier, but you get the idea. And so you can estimate the area of this segment. This would be a negative value. Estimate the area of this segment. You can break it up into segments, right? And that would be positive. And you just find the sum of the two. Positive versus negative, what's the sum? And that would give you the displacement. So anytime that you have an equation where one thing multiplied by another gives you what you're looking for, put one on the y-axis and one on the x-axis and find the area under the curve, and that'll give you what you're looking for. It doesn't just have to be displacement. So those are two different things that can be super, super useful that I want you guys to be aware of. And specifically in this scenario where you're looking at a velocity versus time graph and you can find the displacement, that is something you guys should absolutely be able to do. And that was my quick little thing. Hopefully that was quick and